The music streaming industry is worth over $2.6 billion worldwide. To be competitive in this industry, it's very important to understand what makes songs popular, as well as understanding current trends in the music industry. Today, we are going to be analyzing a set of 30,000 Spotify songs to try to review what makes a song viral, as well as how popular songs relate to each other. Um, this is a description of our data set. We have numerical data like track popularity. We'll be using this to train a model later on, as well as stuff like danceability, which is a measure of how danceable a song is based off user feedback. We also have categorical data like the artist and what genre it is in. Before we can go ahead with making any models, we have to check that we have good data. So the first thing we do is remove any nans. There was very few in our data set, so it was very easy just to remove them all. As well as that, we need to check that we have a good curve of popularity. What we're looking for is a standard bell curve, but what you can see is a massively skewed one with lots of data having zero popularity whatsoever. This data is not actually music which people dislike, it's more music that has had issues with marketing, or the artist is unknown, or the song is completely new. So we can just get rid of this data as it doesn't actually tell us anything. Um, Now that we have some nice clean data, what we can do is have a look at the correlations between different features. Importantly here, we can see loudness and energy are very closely related. Acousticness and energy are very negatively correlated. All sort of things we'd expect, but are important later on when we're making our song. Another thing we can look at here is the density of certain features versus popularity. In duration here, you can tell uh, pretty much all music happens between the range of 0.2 and 0.6, with the majority of it happening around 0.4. Again, important later on. So what we're going to do first is some clustering. What this will do is put our songs into nice little groups and will let us understand how popular songs relate to each other. To start off k-means clustering, we are going to use the elbow method to find the optimal value for k. Um, Here you can see it hasn't worked very well. You can see the elbow does occur at 5 clusters, but we are actually going to be using 4 clusters as processing time for 5 was far too high when I was testing out different features, as well as the fact that the clusters were often much more muddled and harder to understand. These are some graphs describing how our clusters exist in different contexts. So here you can see an energy versus danceability graph, and you can see our clusters quite clearly. We have a big blue cluster here, which describes music which is lower energy, but it seems to have a range of danceability. It also seems to have a wide range of acousticness, but still on the lower end of the energies. And you can also see it has a high range of valence. So this would really be classified as sort of like a kind of quite normal pop music. Um, and then we can also see another group, which is yellow here, which we can classify as more electronic music with its high instrumentalness and its low acousticness. By understanding these graphs, it means that when we create a song, we can make sure it fits nicely into these clusters, meaning it is much more palatable to the average consumer. As we can see, these are our 2 main clusters, blue and yellow. I won't need to go into the rest. So now we get onto linear regression, and this really is what will predict whether a song will be popular or not. So first we're going to use a standard scaler to make sure all of our numerical values are easily comparable to each other. Things that are scaled way out are very bad for linear regression. We're also going to use one hot encoding, so we can use our categorical values as well, like genre. Um, so after doing all this, we end up with quite a high mean squared error. Um, there's a few things that can explain this, specifically the fact that popularity is not something you can really force, right? Popularity is sort of quite a fickle and difficult thing to understand. But you can see here there are a lot of factors which seem to have a positive effect on making something popular. Um, we did try using lots of different things for our linear regression, including a higher cardinality. That didn't seem to help as much as having the categorical data, which was not working properly with higher complex models. Um, so looking at our analysis, this is a graph of predicted popularity versus its actual popularity. As you can see here, it seems to work pretty well between the range of 40 to 80, but works less well at the other end of the spectrum where there is a lot less density of data. Um, Most important thing we can gather from our linear regression model is the feature importance. As you can see here, 4 of our 6 genre features were the most important, followed by energy, loudness, the Latin genre, duration, and danceability. And all this information we can now use to try to attempt to create a viral song. Thank you very much. Bye bye.